Hi guys, we're going to try this again this week and possibly next week live stream. We'll just kind of see how it goes. I am going to do some shorter videos. Today I think it'll be 3 segments. So I know it does get long, so I tried to do it differently this time, where we do a topic and then you get up, take a break, and practice maybe even, and then come back and try a second video and practice, and we'll see how that works, okay? I will have the answers to the practice questions on Google Classroom for you to look at, so hopefully that helps out. I don't have an assignment for you today. Just get comfortable with those practice problems, okay? And tomorrow we will move along and see how it's going. Okay, so today we are going to talk about inverses, and the reason we are talking about inverses is in the next few days / weeks we will be looking at exponentials and logarithms, and they are inverses of each other, but we do need to do at least a brief review of inverses, and it should be a review. Hopefully you did it in Algebra 2, but I know it's been a while and we don't always remember stuff, so let's see what we have. Okay, so we are talking about functions, and when we are talking about the inverse of a function, we are going to use this symbol f to the negative first, okay, or f to the negative first of x. Okay, and so that is our symbol for an inverse. Okay, now what makes an inverse is it has the reverse coordinates, okay, of f of x. So its partner function, it has reverse coordinates. So if f of x had a coordinate of 1, 2, the inverse function would have a coordinate of 2, 1. Okay, so they just flip-flop x and y. Okay. Now graphically what happens when you graph the function and its inverse, it is symmetric, okay, over the line y equals x. Okay, so if we graph a function and its inverse on the same axis, they should fold at y equal x. Okay, and if you think about that real quick, we know a parabola is x squared, and it would have a square root as its inverse. And so if we had half of a parabola right here, and we had our square root function here, we could see that there is a line that they fold on. Okay, now one side note on that is, why did I cut that parabola in half? And that's because you can only have inverses if f of x is 1 to 1. Okay, so not only does our original graph have to be a function, it has to be a 1 to 1 function. So it can't have any repeated x's, which makes it a function. But to make it 1 to 1, it also can't have any y's that are repeated. Okay, so for a function to have an inverse, it only happens if f of x is 1 to 1. I'm sorry if I didn't get that up there. Okay. Quick side note as well, these should be on Google Classroom, so if you want to just watch and follow along, that's fine. If you want to print them off, that's fine, but I will do my best to have written notes for you up there as well. Okay, so to be an inverse, it does have to come from a 1 to 1 function. Okay, and we could take a non-1 to 1 function like a parabola and restrict its domain, so you're only looking at the right half or the left half to make it work. So that's what we do sometime. Okay, so something else about inverses is that its domain is the range of f of x. Now, why does that happen? Okay, that happens because we said we flip-flopped our x and y, and the domain is the x and the range is the y, so when you flip-flop it, then that switches. Okay, so that also means that its range is what? Okay, it's the domain of f of x. Okay. So after a while, we do have to say what our range is or our domain is on our inverse. So all you have to do is find the range of your original function, okay, and that will help us out. Okay. Okay. And then something else we need to look at today is that when you take a function and its inverse, and we do this, do you remember what that little dot means? Open dot. That's a composition of functions. So when you do that, okay, it always gives you x. Okay, they undo each other. Okay, and that happens if you do it both ways. So if we are asked to algebraically prove that two functions are composition or are inverse, all we have to do is take the composition both ways, and if it equals x, then we'll know that they are inverses of each other. Okay. Now, first question we'd like to ask. Okay, so part one we'll say, is there an inverse? Okay. So right now we're just looking at some basic things. Okay. And we want to see, is there an inverse? Okay. How do we know if there's not? Okay. Or if there is? Well, the biggest thing is it one-to-one? Okay, so that's what we will be looking for. So let's look at a graph quickly. Let's say we have an upside down parabola. Okay, is there an inverse for this graph? Okay, well, first of all, is it a function? Yes, it passes the vertical line test. Okay, now is it a one-to-one function? No, it fails. Okay, so is an upside down parabola, does it have an inverse? Okay, and the answer is no. Now, how can we make it have an inverse? We could restrict it. Okay, but with this graph, we would say no, it does not have an inverse. Okay. What about a sideways parabola? Okay. And the answer here would be yes, because it does pass the vertical test. It does pass the horizontal test. It is one-to-one. So yes, it would have a inverse. Okay. Now, am I asking you to find it right now? No. Okay. What we would do on a graph is we would do the line y equals x, and then we'd reflect it over it, and then we could find it. Okay. Okay. How about, give me a second. We have a table here. So if we have -3, -2, -1, 0, 2, and 3, and 10, 6, 4, 1, -3, -10. Okay, so why don't you look at that a minute and think to yourself, is it a function or, sorry, does it have an inverse or not? Okay. Well, we just want to know, is it one-to-one? Okay. Do we have any repeated x's? Okay. No repeated x's, so it is a function. Okay. Is it a one-to-one function? Okay. Yes, because there are no repeated y's. Okay, so does it have a inverse? And the answer is yes. Okay. Now on this one, could you tell me what the inverse is? Okay. Well, all we have to do is flip-flop. Okay. So instead of -3, 10, we're going to have 10, -3. And instead of -2, 6, we're going to have 6, -2. Instead of -1, 4, we're going to have 4, -1. Okay, and just continue switching. And notice that is what we would have. Okay, so, and in this case, this would still be the x's, right? And this would be our y's. Okay, so this would be the inverse. Okay. Now, I'd like you to take a minute, and why don't you go in your book to page 240, okay, and answers problems 27, 28, 29, and 31, and then check it with the answers on Google Classroom. Okay, and so we'll call this our first video for the day, and I'll see you in a few minutes.